Okay, we are going to discuss today sustainable designs and reducing carbon footprint of green buildings. Well, briefly, I will try my level best to complete it at the allocated time. Now, green buildings, well, it is a very common subject at present. Green buildings are more and more popular in the present day. Why? Merely to reduce energy in buildings. Now, green building certifications such as LEED, I think everybody would have heard this LEED from USA, of US Green Building Council, and ASHRAE Green Building Standard 189 has been the prime tools for achieving green buildings states in the world. There are a few other certification methods like BREEAM in UK and various other things. Rating tools of Green Building Council in Sri Lanka, that is GBCSL, are predominantly used to certify green buildings in Sri Lanka and also becoming more popular day by day. Now, to commence, what is a green design? What is a green design? Will it be a green color building or more foliage, plants? No, what is it? A design that is green is one that is aware and respects the nature and the natural order of things. It is a design that minimizes the negative human impacts on the natural surroundings, on materials, resources, and processes. In nutshell, this is a green building. Then comes the word very frequently we hear, sustainability, sustainable. What does it mean? Well, there are so many definitions to sustainability. However, ASHRAE define this. What is ASHRAE? We'll come to that later. ASHRAE defines it providing for the needs of the present without detracting from the ability to fulfill the needs of the future. Now, if you try to understand this, providing for the needs of the present without detracting from the ability to fulfill the needs of the future is known as sustainability or reduce waste. Keep it for future use, in few words. We can't waste anything, not even energy. Every day, if we having our lunch or dinner, at the end we throw some portion. No, that is bad. That is bad. Similarly, energy we can't waste. Now, measures of green design and sustainability. Now, green design and sustainability have no absolutes. No real absolutes. They cannot be defined. Actually, exactly, we can't define that. But it is a goal to be sought. It is some practical techniques to help practitioners achieve the goal of green design and thus make a significant contribution to Earth's sustainability. As we know, global warming will increase surface temperature of Earth, and a sea level is rising. The island nations like us, we are in a great danger. When the Earth's temperature rises, it is huge threat to humanity. So sustainability will somewhat resist to this global warming. That is one of the aims. Now, Sri Lanka Green Building certification is available from Green Building Council of Sri Lanka. When you rate a building as certified rated or silver rated or gold rated or platinum, you somewhat ensure you have a sustainable building. There are 8 parameters we'll discuss later. Ultimately, we ensure reduce waste. Now, Green Sri Lanka SL rating system is available from Green Building Council Sri Lanka. It is for built environment, that is a set of performance standards for certifying built environment in the form of commercial or industrial and high-rise buildings of all sizes, both public and private. Intent is to promote high performance, healthy, durable, affordable, and environmentally friendly sound practices for new and existing buildings. Now, these words, high performance. Now, when you compare a normal building, the green building would be a high performance building for the given footprint. Total energy consumption is fairly reduced, thereby carbon emission is reduced. So you call smaller carbon footprint. And it is a healthier space because occupants' well-being is an important factor in these green buildings. And durable, affordable, and environmental friendly. Now, these things are key factors of green buildings. Now, this rating system at present, it is version 2, 2018. Most probably there would be a version 2.1 very within few months, I suppose. Now, this rating system has prerequisites and credits in the green rating system. Now, if we name it, there are 8 goals: management, building management, like building commissioning, building tuning, various things. Sustainable sites, you'll have to ensure that you build a new building is sustainable in a sustainable site, or add more sustainability for a existing building. Then water efficiency, you minimize the water consumption. That is another important factor. Energy and atmosphere, that is energy, and at the same time the harm that we do to atmosphere is minimized. material and resources, how to use materials, sustainable materials and resources. Then environmental quality, that is more into a well-being of occupants, providing adequate outdoor air for respiration of oxygen. That is one part, and maintaining comfort. Likewise, various things. Innovation and design processes, and social and cultural awareness. So these 8 things will be very seriously addressed in green SL rating. Now, just to give a very brief idea, we'll just compare a green building versus a normal building. On to your right is a green rated building, building B. On to your left, building A is the normal building. We'll assume building A and B has similar floor area. But building B is certified building by Green Building Council Sri Lanka, let's say, and awarded platinum rating. Now, such a building would provide, say, energy reductions, say 35%, water use reduction 45%, carbon footprint reduction 30%. Now, that is called a green building. Now, in this lecture, we focus more on to reduce energy consumption of a building to achieve sustainable goals, because there are so many other presenters giving rest of the areas. Now, 2 significant areas that we are discussing today. A building envelope, or we call building fabric. Now, building envelope comprises of walls, windows, doors, roof, floors. That is a building fabric. One of the main aims are reduce heat transfer from the building envelope. Reduce lighting load by utilizing energy efficient fittings. Another goal to seek. If you want to go for a green building, you may not be able to just use normal lighting. There are lighting power densities as a target. We'll discuss. Reduce small power loads. Reduce power from HVAC equipment. All that comes in this attempt. Now, where equipment utilized is concerned, select energy efficient equipment, select all other equipment with star markings, and lighting. So, I mean, this is in a mix. So, building envelope and energy use has to be reduced. That's what we are going to discuss in depth. As we know, we are in a country that we have abundant sunlight. We are in a tropical climate. So hot and humid environment. Obviously, there will be heat transfer from outdoor to indoor. Example, our outdoor conditions. Colombo and suburbs, or almost, other than the hill country, it is somewhere around 32 degrees C to 34 degrees C. For our comfort, we normally keep in indoor conditions around 24 degrees C. So there will be a temperature difference, 32 to 24, 8K delta T we call. So that temperature difference force heat to transfer into the building. Now that will increase energy consumption of the building. Now we'll have to reduce that. ASHRAE standard 90.1. ASHRAE is American Society of Refrigeration and Air Conditioning Engineers. That is the largest institution in the world, engineering institution, having 55,000 members, around 190 countries. In Sri Lanka, we have the ASHRAE chapter as well. They are responsible for producing standards for built environment and energy, so forth, air conditioning, refrigeration. So we are utilizing these standards when we design a green building. ASHRAE standard 90.1 is energy standard. Our Green Building Council rating system is using that intensively. Now, in order to reduce heat transfer from outdoor to indoor, we'll have to make some building fabric elements resistive to the heat flow. In engineering, we call resistance to thermal flow, thermal resistance, given by R value, and the total heat transmission of the structure is given as U value, watt per square meter Kelvin. Now, we need to reduce this overall heat transfer coefficient, transmittance, in order to reduce our building energy use. These standards, ASHRAE standards, these are few of their hundreds of standards there. These four are being used in green buildings, especially GBSL green rating system. 90.1 energy standards for buildings, 55 thermal comfort, 62.1 indoor air quality, and 135 backnet for BMS. Now, ASHRAE standard 169 also used to find our building or our country where it is situated, and this will give a climate zone, a particular climate zone for our country. With that climate zone, we can find data in 90.1 standard to comply. Now, for instance, you can build a house in Sri Lanka, or in Japan, or North Korea, or UK, or New York. But you can do the design here. How? We'll have to find the climate zone of that particular area and select envelope details like U factor, R values, and then we'll instruct. If it is a new building, this is how you should construct to minimize energy consumption. So climatic data from 169, all the countries in the world, they are categorized into 8 climate zones, 0 to 8. 0 to 8. Sri Lanka being under 0. And there are certain other categories. 0, climate zone 0, A, B, C. Now 0A, extremely hot and humid. Now as you can see, we have 2 areas. White is 0A, extremely hot and humid. B becomes extremely hot and dry. But we have hill country, it is colder weather. Unfortunately, we don't have a meteorological stations other than the Katunayaka airport. So we don't have published data in ASHRAE other than Katunayaka. So this is how we find our climate zone from ASHRAE standard. Katunayaka, the WM station is 434,500, latitude 7.1, and the climate zone is 0A. Now, if we know 0A, we can now refer back to 90.1 and get all the details of the building envelope, not even building envelope. So many other things, especially building envelope data is given in the climate zones. Now this is a typical table. Roof details, wall details, floor details, opaque doors details, all that is given in 0A category. So when we build a green building, we'll have to adhere to this. Okay, we'll now concentrate on reducing building envelope heat transfer. ASHRAE 90.1, this is the standard. The latest one is 2019. This is a continuous managed standard. That means every year it is reviewed, and probably every 4 years they will come up with a newer version. So at the moment 90.1 2019. Now building envelope, all this heat transfer, why we are worried about heat transfer? Because that heat transfer creates an environment that is very unpleasant, unhappy feeling, no thermal comfort as such. That is only discomfort, unless you bring that into a comfort zone. So before doing that, we are now going to reduce the heat transfer. Then we must understand what is the key factor for heat transfer. That is that heat transmittance. I'm not going to go in details. The U factor is given as watt per square meter Kelvin. In SI units is the amount of heat in watts that flows through a 1 square meter area with 1 degree Celsius temperature difference. Now U factors are given for different exposures. Now all these walls are not homogeneous single pane structure. It is a combination of structural thing. We call that is a composite structure. If you take a brick wall, you have a cement plaster outside, then brick wall, then gypsum plaster inside. Now what we are telling, the U factor which is given, maximum U value is given by the ASHRAE for climate zone Z, will have to achieve. Fortunately, for a green buildings, the target U values are well ahead than what is using in Sri Lanka. That is cement hollow blocks, bricks are quite good. We don't need to do any thermal insulation, nothing. They are quite good, but still we can improve heat transfer. This is how engineers find the U factor for roof, entire construction, mind you. Now here U factor comprises of a roof and then attic and then a drop ceiling. You can see a roof structure and then an attic space and then a ceiling. So we calculate the U factor for entire structure and compare with the ASHRAE values and try to reduce the heat flow. Similarly, wall U factor, we calculate like this. I'm not going into details. On the right, you have a picture, not for this climate. Of course, this is for a colder climate. You can see brick wall outer and a mineral fiber thermal insulation and an inner side another layer. Now we don't need thermal insulation by default, we don't need. Right. Now I'm going to give you a simple comparison of U values used in Sri Lanka. Now on your left, what you get, all the U values that we use normal building envelope materials, the structures, their U values are given in the left column. Right column, our target values. So then you can imagine this is watts per square meter. Watt per square meter Kelvin. One square meter, how many watts is transferring? Has to be reduced. You can see. We'll go through quickly. Roof, concrete slab 150 millimeter. Nothing, no thermal insulation. Then it will be 2.26 watts per square meter. But it has to be reduced to 0.22. Now this is green building. This is green building. Of course, green building has a slightly incremental cost, but having a payback, good payback. Now, concrete slab with acoustic tile, obviously you can see the U value is reduced, but still further reduction required to make it to a green building. Concrete slab with polystyrene insulation 0.58, that is quite good, but still you have to drop it. Can you see? So you need more thermal insulation. Asbestos roof with mineral fiber ceiling 1.39, but our target is 0.153. Zinc alum roofing without anything 5.88, disaster. No, zinc alum roofing with glass wool 50 millimeter. That is the Sri Lankan specification. Everywhere we do that. So you have 0.83 watt per square meter Kelvin. Very good compared to other structures, but you'll have to further reduce to 0.2. At the same time, you can see brick walls. We have 1.84, but our target is 3 points, so we don't need to do anything. These are quite good. Cement hollow blocks, quite good. Just a comparison. Now, another thing, cool roofs are encouraged. What is a cool roof? Cool roofs are recommended for roofs with insulation entirely above deck and a metal building roofs. In order to be considered a cool roof for climate zone 0 to 3, that is our part of the world, following conditions has to apply. The roof has high reflectance. High reflectance keep much of the sun's energy from being reflected, not being absorbed. That correct this. The roof has a high thermal emittance. The high emittance radiates away from source. So now, answer is there are some paints we can apply. White color being the best for reflection. I don't know how these zinc alum roofs are becomes blue and green color, red color. It has to be light color. So that will keep out heat. So it become a cool roof. Now quickly go through roof structures. There are 3 types of roof structures available. One is roof insulation entirely above deck, that is concrete roof. Now I have calculated the roof, the U value and the thermal insulation required for Sri Lankan climate. Will you believe we need 6.5 inches thickness or 160 millimeter thickness polystyrene insulation, not 50 millimeter, remember, not 50 millimeter, for concrete slabs. Now metal roofs, you need 2 insulations, one for a cavity and one for the main insulation, fill cavity. Now we can see R value are 10 for the normal thermal insulation for the roof, and the cavity 19, R19. So that is, you need 3 inches and 5 inches rock wool, about 8 inches. What we do instead, we have 2 inches thick, 50 millimeter glass wool. So remember, a normal zinc alum roof with 50 millimeter glass wool will not comply for a green building roof. You'll have to increase the roof insulation. If our green building associates listening, you got to remember, you'll have to provide proof of these things when you are going for rating system. You just can't say comply. We have complied 90.1. No. You'll have to give all these salient figures to analyze. If it is an attic roof, that is common in Sri Lanka, you need 10 inches thick rock wool. 10 inches. Will you believe this? Will you believe? 10 inches. Yes. If you need a green building, you got to do this. Then we go for another element in the building fabric, that is walls. One of the newest kind of wall elements, that is aerated autoclaved concrete, very lightweight with air bubbles inside and very low heat transfer. Now we are blessed because AAC blocks are being made in Sri Lanka. I personally did a project, but during that time we didn't have AAC blocks. We had to import from Bangkok. At the end of the day, that project, I got really scared myself because we might lose our industry. We will have a problem if we have real green buildings, because if it is air conditioning, You don't need air conditioning. You need very small air conditioner, especially with aerated autoclave concrete buildings. Now you can see the thermal conductivity values. AAC block 0.122 watt per meter Kelvin, concrete block 0.5, brick 0.8. So it is superb material for walls. It will have reduced dead loads, and they are using fly ash 70% by weight, so sustainable product, and excellent acoustics and fire resistance. So other than bricks and the cement blocks, if you are going for a green building, consider aerated autoclaved concrete blocks. Then we are coming to other building fabric element, fenestration, windows and doors. Now mandatory provisions require the fenestration and doors rated using the section 5.8 or our rating system, where there's another number. You'll have to have particular U factor, that is ASHRAE 90.1 will have to comply. Solar heat gain coefficient, again you'll have to comply. Then visible transmittance over SHGC, those values are given by ASHRAE, will have to comply. Now you can see ASHRAE fenestration data for climate zone 0. This is SI. First thing, vertical glazing is allowed 0 to 40%. 0 to 40%. Non-metal, that is wood framing, U value should be 1.73. Now for you to understand, I'll give you something. Now see, this is a block wall section and this is a glass. Now you can imagine how the resistance in these two structures. Wall somewhat reduced, but glass, it flows heat quickly. Now the U value of a glass is almost 6 watts per square meter Kelvin. Normal glass. Now mind you, you'll have to drop that 6 to these values. Metal framing, it should be 2.7. How to do that? That is the HVAC engineer and the green AP's job. It is not just 6mm glass. Now you have to find other ways. You have to trial and error, find, okay, 6mm glass with another coating, tinted coating, whatever. Find the resultant U value, whether it is 2.7 or somewhere close to that. Then you'll have to introduce double glazing, or ultimatum is low EGlass. So that shows you can't just have a normal windows in a building and call that is a green building. Would you do that? No, you can't do that. And the values for solar heat gain coefficient is given here, and BTU over SHGC given here. Skylights. Now skylights are not meant for Sri Lankan climate. They are for a colder northern European climate, because they don't have heat, they don't have sun, so they invite sun. We have more sun, we don't want sun. So only 3%, 0 to 3% skylight is accepted. But my personal experience, personal suggestion, you don't have skylights. Because you may think you get light, but your repercussions on heat transmittance is much more. Window wall to ratio should be selected between 20% to 40%, and the and the and the results 30% saving. This is low EGlass, two glasses with inner glass. You have a rather outer glass, inner side you have a coating. Low EGlasses. Now, I'm really doubtful how someone use 9mm glass plane and try to comply 90.1. You can't. Next thing, for fenestration, it is suggested to have permanent projections. Permanent projections, especially on west and south and east sides. Projection factor shall be 0.5 or larger. Now, what is projection factor? Is the awning width divided by the height of the projection from the sill level. You can see when the projection factor becoming higher and higher, your SHGC, that is solar heat gain coefficient multiplier, becoming smaller and smaller. So your heat transfer reduces. Yeah, in the chat we have a couple of things. We'll take it once we are coming to the end. The other thing for a green building, but this is not a mandatory, but if it is possible, yes, continuous air barrier. That is, in the building, in new buildings, of course, you run a air barrier right around the zone. Now, these are mandatory in other part of the world, but well, I had a chance to do a building in Sri Lanka with a continuous air barrier, and to get passive house rating for that. It is very high rating. This will reduce infiltration, and that is a huge load in Sri Lanka. Next focus is energy efficiency. 90.1 has energy efficiency section. Now, whatever the HVAC equipment we use, it has to be really energy efficient. Now, if you take a commercial building, 60 to 70% goes for air conditioning system plus lighting and few others. So, prime importance is to have energy efficient equipment. Equipment energy efficiency is given as kilowatt per ton or COP, coefficient of performance. Now, if it is in kilowatt per ton, 1 kilowatt per ton is baseline, but it is not efficient at all. 0.8 is not efficient. 0.6 kilowatt per ton is taken as efficient equipment. On the contrary, COP, other side, COP 4.3 is not efficient. COP 5.8 is taken as efficient. And another problem with this HVAC systems for buildings, the cooling load is not constant throughout the day. It varies the day because of the heat transfer varying. Heat generation is varying throughout the day. So, If you select the equipment giving a very good efficiency at full load, that may not be the case in actual. The building behaves in a part load, more operational side on a part load operation. So it is, we call a part load intensive application. Some buildings are almost in the full load but slightly on the part load, like office buildings. If a building operates 24 hours, definitely it has a part load operation. So the efficiency also given as part load. So we call integrated part load value. We'll have to check that as well. This is how the efficiencies of chillers, air conditioning equipment is given. 0.7, 0.6, excellent, 0.5, yes. What you can see here, ASHRAE 90.1 compliance for a air-cooled chiller, this is air-cooled chiller and water-cooled chiller, 75 ton and below. What is your required full load efficiency? 0.75 kilowatt per ton. Part load efficiency 0.78, something like that. Part load efficiency is 0.6, sorry. 0.75, 0.6, that is part load and full load. Part A, part B is a different scenario. Part A comes as the full load intensive applications, part B for part load intensive applications. So that's how we select chillers, equipment for green building. So why I emphasize this, our own green practitioners has to be very careful. You'll have to do a real selection and provide proof for rating. You can't just say this, we have a building model and we have a 30%, 40% saving on the model. No, we got to show your actual building has equipment complying 90.1. So this is how you select chillers. And just to give us some idea, there are so many chillers, so many compressors in the world, but there are two categories give high performance. One is tri-rotor screw chiller that will give very good efficiency, 0.52 full load. And another chiller with magnetic bearing, that is a high efficiency chiller. But both of these are quite efficient in part load applications. So we got to be very careful how we apply these things. Then air conditioners, we have DX split units, unitary air conditioners, very common. It is you have in your house, bedroom, your office. Now the efficiency is given as energy efficiency ratio. Energy efficiency ratio. What is energy efficiency ratio? Just simply divide the cooling capacity in BTUs per hour by power input. You can do that. Anybody can do that. So in future, when you try to buy an air conditioner for your home, don't go for the make. Don't go for the make. Don't go for the first cost. They might tell you, we'll give you fantastic discount. No. Go for EER, energy efficiency ratio. Now, earlier, this is very stringent. 1 year, 2 years back, it was 11.3 EER. Unfortunately, Sri Lanka, what we get, maximum 9. Very, very recently, a few days ago, I was in a panel doing a rating and they have submitted 7.8 EER. And they think they will do a green building. No, out. So that means you can't just over the counter buy air conditioners. You'll have to find the efficiency if you want to do a green building. that will have a immediate impact on power. Large equipment, also same. You have EER given here. SEER is seasonal energy efficiency ratio. You'll have to divide by 0.8 to find the EER. Seasonal energy efficiency ratio is for countries with winter. So it is about 11.3. Now, we know VRF and VRV, variable refrigerant volume air conditioner, is very popular for two-story buildings, very popular, quite energy efficient, but people are carried away. They just say, oh, okay, we have VRV, so it's a green building. No. Again, there's a cap. You'll have to get a VRV with a right energy efficiency. Right energy efficiency. That is 11, 11.3, 11.2 ER. I'm talking to you with experience. I've done a lot of green buildings. It is not that easy. It is not that easy. You got to talk to your supplier and tell, look, I need 11.2, not the normal one. Similarly, cooling towers has another measure. It is a water flow rate per horsepower. Water flow rate per fan motor horsepower. And it is given here. So we'll have to comply that. 40.2 GPM per horsepower in IP units. Air handling units. Similarly, you have the same thing. Constant air volume, normal air handling units. Horsepower can be calculated. How? Supply a CFM into 0.011. Say, for instance, we have 3000 CFM HU. Now, constant volume, 3000 multiplied by 0.0011, that gives you 3.3 horsepower. But when you check, it is 5 horsepower fan motor. So it is not complying. No, it is having more power, more huge power consumption. No, this is the limit. You'll have to satisfy 90.1 with 3.3 horsepower. Yeah, that is how you apply this. Similarly, thermal insulation. Just you can't use thermal insulation. You'll have to calculate the thermal insulation thickness as economical thickness to prevent condensation. But once you do the calculation, you'll have to find the R value. So these are the R values we are supposed to keep for climate zone 0. Exterior R8, buried ducts R6, indirectly conditioned space 1.9 or 2 or 2, something like that. Piping, similarly, you have R values. Right. So we discussed about air conditioning equipment in green buildings. Now quickly, we'll go to other equipment. Obviously, a green building has so many other equipment. Probably you may be having photocopiers, printers. Obviously, you have a refrigerator. Likewise. Now, these things has to be energy labeled equipment. As a matter of fact, even air handling units, you can't just because you have complied to a horsepower limitation, that is fan power limitation, you'll have to comply again for the labeling. So every HU has a label, every refrigerator has a label, star labeling. Otherwise, you can't put a refrigerator, unfortunate, because this is a green building. Then comes the lighting. I have seen people discussing coming with the green building details. they just provide switches for all the lighting. No, it doesn't mean there will be a power saving on lights. You need automatic switch off. You need automatic switch off. Sensor lighting. Sensor lighting. Not even that. Lighting power densities. Lighting power densities. Now usually non-certified building has a power density of lighting 15 watts per square meter. Normally we take this for our cooling load calculations. But you can see now ASHRAE target, let's see, office. 8.8 watt per square meter. How do we do that? You'll have to find light fixtures with lower power. Then obviously you must have a building management system. I'm not going to go in details. Without a building management system, we can't see that you are having a successful green building, because so many energy saving strategies you can do with the BMS, like chill water reset, fan cycling, demand limiting, night purge, so many things. So you need a BMS, a true BMS, not a BMS that you look at the pictures and the moving things. No, actual saving, power saving. Now this is a picture I took one of my projects almost 2 o'clock. A chiller is running, present load is 71%, part load. Building cooling load is satisfied entirely. Of course, there are so many other factors, so many other things used to achieve this. Next one is indoor environmental quality. We'll quickly see what this is. We have a ASHRAE standard to comply, that is 62.1, ventilation for acceptable indoor air quality. Now there, we'll have to provide outdoor air for every air conditioned space. For respiration, we need oxygen, dilution of carbon dioxide, dilution of any volatile organic compounds is a must. Now, for instance, one small office, one person, two people, door is opening to outside. You don't need fresh air, because door openings will have infiltration that will satisfy this. Unless otherwise, you'll have to definitely provide outdoor air. Now the question is, outdoor air is at 32 degrees C at a large moisture content. Usually Sri Lankan weather, 20 grams in 1 kilogram of air. 20 grams of water vapor in 1 kilogram of air. Now that for comfort conditions, we'll have to drop it to 10 grams of water vapor to 1 kilogram of air by air conditioner. Now all these need energy. That means supplying outdoor air means energy. You need large air conditioner. So you'll have to mitigate this. How to mitigate? You'll have to apply, you'll have to use treated fresh air units or energy recovery ventilators. I'm discussing that. To comply this rating system, Green Building Council Sri Lanka, you need to comply another thing, outdoor air delivery monitoring. We need outdoor air delivery monitoring. What is the CO2 level? CO2 meters has to be used. And the filters, you'll have to use certain high grade filters like MERV 13, MERV 8 filters. Now, air handling units, you must have MERV 13 filters. And outdoor air intakes, yes, for PM 2.5 micron filtration. PM 10 filtration, larger particles, you need MERV 8. So, if you use MERV 13, it is fairly okay for a COVID mitigation. Another advantage. Then thermal comfort, also another part. Now, most of the air conditioning systems are thermal comfort. So we'll have to prove the people are comfortable. How do you do that? We have a tool to do that. Now, what is thermal comfort? Thermal comfort is in our mind, which express satisfaction with the thermal environment. Okay, but it has 6 factors affecting thermal comfort. Our metabolic heat production, our clothing, and physical factors as air temperature, radiant temperature, relative airspeed, and humidity. I'll give you an example. At home, you're seated in your lounge, a shorts, no slippers, with a t-shirt. You're very comfortable because a house you have natural ventilation. It doesn't mean your office you can provide natural ventilation. Why? Your attire in the office is totally different. You have more clothing and body temperature increases. So you are not comfortable. So all that is in combination will affect our thermal comfort. It is measured, it is called predicted mean vote. I'm not going into details, but to comply, PMV has to be within this range, -5, +5, and dissatisfaction should be below 10. So now we'll have to prove this. We have a computerized tool. With that, we'll have to take typical zones in the building and provide details of PMV and whether it is complying 62.1. That's how you can go for green building. And also in buildings we have high occupied areas like banquets, the seminar rooms, high occupation. That is called high densely populated area. We call that is 25 people per 100 square meters. 25 people per 100 square meters. Such areas, you should use energy reduction method called demand control ventilation. If you are using outdoor air over 3000 CFM or 1400 liters per second, you need demand control ventilation. How do we do that? We use a CO2 sensor. By detecting CO2, we change the fan speed. That will have an enormous power saving. For fresh air, for car parks, we use CO sensors. Nowadays, car parks, 8 hours fans are on. When you put these sensors, CO sensors, total running hours may be 2 hours, 3 hours. Enormous. Power saving means your energy consumption lower, your carbon footprint is lower. Now, when you are really compelled to provide outdoor air for occupant well-being. But outdoor air has a lot of energy problem. So you need to have energy recovery system, air-to-air heat exchanger, recuperator, like this. Or you have to use the energy recovery ventilator with a energy wheel, enthalpy wheel. Now such equipment is energy recovery ventilator with a thermal wheel. What it does, the extract air from the office at 24 degrees C will cool incoming outdoor air 32. Not even that, enthalpy wheel will absorb water vapor. So moisture reduction, enthalpy reduction. So your power consumption drops. Then the other one is recuperator for normal split units. You must use this energy recovery ventilator with the recuperator. It doesn't have moisture absorbing capability, but still it will cool the outdoor air to a certain extent, probably 26 degrees C. So that will reduce a power consumption of your air conditioner. So you got to follow ASHRAE green guide as well. That will give you green tips. Finally, carbon footprint. Now, what is carbon footprint? The total amount of greenhouse gases produced directly and indirectly support human activities, usually expressed in equivalent tons of carbon dioxide. Actually, green APs are calculating embodied carbon for the construction of building, and the live carbon that we discussed today, just because of equipment and the energy transferred inside the equipment power. So that will contribute to live carbon. The mitigation of carbon footprint through the development of alternative projects such as solar, wind energy, or reforestation represent one way of reducing carbon footprint, and is often known as carbon offsetting. Now, CO2 emission can be calculated by using this equation. CO2 emission per year for electricity. Kilograms of CO2 emission per year equal total kilowatt per hour in a year of the building into emission factor. Now emission factors are given in a table for natural gas, the propane up to diesel. So you pick one and calculate. Now this is in metric tons of CO2 emission per kilowatt hours. Now if it is pure diesel, you can take 2.51 into 10 to the power minus 4. But in Sri Lanka, you have a mix, unfortunately. There is hydro and thermal. So the energy mix is given 5.835 10 to the power minus 4. Now you can multiply this with your energy consumption per annum and find the live carbon emission. Now this figure is given by engineer Senapiris. Thanks for him. So reducing carbon footprint is reducing reuse and recycle principle. I'll give you a bit of example, you to just understand. Now this is not a green building though. How the carbon footprint is reduced. This is a Ceylon Towers in Kolpiti. Now Ceylon Towers, of course 1995 I designed the building for tender. That is long time back. Now I got their annual power consumption January 2012 to December 2012. So you have total kilowatt hours 4.7 million multiplied by 2.51, we'll assume that is diesel. and your metric tons of carbon emission is 1200 per annum. Okay, fine. Now, during September 2015, the chiller was replaced with a magnetic bearing chiller with a very, very uh, intensive real building management system. The result was I have another annual consumption. Now the result is a annual consumption now 3.1 million. It was 4.1 million, now 3.1 million. So energy, carbon dioxide, metric tons, emission 786. Can you believe that? So you have about 35% of carbon footprint reduction. Now that is what we should achieving in green buildings. Green buildings is not a myth. It is practically we should achieve.